Hi, this is Austin with Sprint 5. I'm going to lead with Task 4 because that was the one that I couldn't get working. But I do want to show that at the very least I can calculate the normal and adjust based on that. But the problem is, if I turn around and keep going, it's still using the same normal, so I continue to go upwards rather than downwards. And I think the problem there is that I need to rotate by the adjusted up vector rather than just by the y-axis, so that it's actually moving downwards instead of upwards. But the problem was I wasn't entirely sure how to do that, so I just and this is even just with the regular non-barymetric version of the normal calculation. But I did get everything else, all the other three tasks working, so I will show that off. So for task 1, you can see it highlighting the spot right beneath the tank. So there's that. I'll switch that off now and turn on the highlight all cells option instead, and do that. So there's task 2. The yellow ones represent the ones that are in the B-sphere but are not colliding, and then the red ones represent the ones that should be colliding. And some of the AABB to OBB collision is still a little wonky, but it should give you the idea of that it's checking the ones that it is and isn't colliding with. And as I get further away, you can see that things will be a little further from the thing, so now I'm not colliding with them anymore. And if I come over here, I should start colliding with more of them again as I clip into the mountain here. So there it is. So pretty much all these calls that I was making were in the new terrain model class. So this is all going to be the same as graphics, except I'm also generating AABBs. Well, I'm not actually generating the AABBs, but I'm storing a min and a max to be used, as well as just the bottom, top, left, and right of the cube for use with the normal calculation that I'm currently doing, and should still be useful with the barymetric, because all of these vectors have, or all of these have built-in normal, so I can just change these over to NX, NY, and NZ and get those. Yeah, here I guess I can show off that I can draw all of the AABBs at once, and you can see everything. And it's lagging horribly because there's so many of them, but I wouldn't normally be having that on. So the highlight cell, it just gets to target X and Y based on the vector. Then it moves those. It calculates the texels based on that, and then finds the appropriate one, and then uses that to call the show ABB function, which there is one for a min and a max value, and a color, of course. Then there's a snap to cell, which is a special thing that I added as part of my game. Essentially what I do is, so that I can I don't have to figure out the heights for the enemies on the terrain, I just spawn them all really high and use this function to snap them down so that they'll be directly on top of the terrain. And if I turn on my enemy spawning, you'll see that, because the other enemies will be a little higher than they'll be a little higher up or further down than the tank. So I'll do that real quick. So there it is. You can see some of them spawned low, so they snap down there, and then other ones were about the same height as me, and that's just they snap down to the terrain that they were directly on top of. So back to the terrain model. Get face normal. This is just my code for finding the normal of the cube I'm on. And it's a bit wonky now because, like I said, I realized midway through that I wasn't going to be able to actually get the ship tilting fixed in time. So if you see any problems here, I wouldn't be terribly surprised, but this does at least It seems to at least cover most of the cases from the testing that I've done on the tests, the TEST height map that I was using for that. And the highlight all cells just gets all the cells in between the min and the max by calling there, calls twice, picks all the ones in between, and I also have here just the it checks the intersection with the B sphere, checks collision with the collision volume, and that determines what color it draws as. So, and then up here is where I am now calculating the world matrix based off of the face normal, or at least part of the world matrix that is. And right now, for testing purposes, I just have it set to 0, 1, 0, but you can see here the get face normal is how it determines the subvector, and then calculates forward and right based on that. And that was the way I was doing it in the initial test I showed, where it was actually rotating off the terrain. So that's the code I have for that. And then I use the forward vector to determine what direction I move, rather than just rotating a 0, 0, 1 vector. So real quick, I want to look at some of the things I didn't touch on last time, such as the layered collision. You can see here that I do the collision with the default sphere ahead of time, and I just return if it fails, and then I keep going. That's the only change to this one, because this is a self command. The pair command has a much bigger series of checks, and these are just the order of the ones we talked about in class. So, and then for the collision manager, you mentioned that I was incrementing the iterator twice, and I'm guessing you were talking about this, but this is actually a separate variable that I'm using to iterate over a certain part of the list, because the list does have a lot of null values, so I can't just iterate to the list's end by using is not equal to the list.end. So that's a necessary change, and as far as I can tell, that's only being incremented once, so that should be okay. Now I will go through my personal project. So spawn 3 enemies now, because that's what I'm trying to do, is have it work with multiple enemies. So I'll bring them over here so that they will be far enough away that you can actually see the effects, so that should be close enough. I'll wait for them to catch up. They're all nicely going in a row for me. That should be close enough. I'll pause, quote unquote. I'll hit backspace to save that. I will unpause, and they are still over there. The player resets its position, which I forgot about for a second, so that's why I paused. But yeah, so they still remain over there, both in-game, and if I restart and use the recreate function, the load game function rather, they will still be over there. So that's that. And I'll look a bit into the functionality to hopefully alleviate some of your fears, or some of your concerns, I suppose would be a better word. So I'll show you what's on the player side and what is on the engine side. So the player is responsible for implementing the recreate in the way they want to. So the way that I'm having the user, quote unquote, which is me, do it now, is they just loop through all the storable manager, and get count, by the way, represents how many things are currently stored, and since all of them will be of the type enemy, I just automatically call override on the enemy manager, call deserialize to get the data, and then pass that into the enemy manager, which then overrides the enemy, and then increment the offset to get the next storage node from the deserialize function. And the enemy has store and recreate, where it just passes in 2 matrices and 2 vectors to the storage mode, and then we'll get those back later. So the storage mode is a special class as part of the storable manager. And by the way, this is what the storable class looks like. So overrideable store and recreate classes, or functions rather, and whenever one is created, it automatically tells the storable manager to store it. So the player doesn't have to manually register anything for save and load, just has to tell it what to do when it is saved and loaded. So I have a list of storables. I have store, serialize, deserialize, read and write from file, and then get the buffer and get the count, the number of objects. So let's see. Look at the C++ file real quick. So serialize all, what it does is it loops through. It creates a storage node, has the first storable store in that node, copies it to the buffer, and then keeps going for all the storables, and then it sets the storage count based on that. And whenever deserialize is called, it will get one node out and return it, and then it'll be the student's job to determine what to do based on what's in that. So at some point there will probably be a string of some sort to determine what object that is, and the scene will be in charge of knowing what to do with that type of object, but not now. And then the read and write from file. So it is certainly a very specialized implementation. The user will have to do a decent amount of work, but you seemed concerned that the user would have to do everything. And that was just for my proof of concept to demonstrate that all these concepts worked. So hopefully seeing it actually in the engine should show that the engine is doing a decent amount behind the scenes of actually storing and loading everything. It's just up to the user to determine what to do with the stored and loaded data. So quick post commentary here. Everything past this point is just talking about the documents, so I don't know if you're planning on reading through those on your own, but since I know this is a long video, I just thought I'd let you know that in case you don't want to listen to me ramble about this thing that you might read anyway. So now that I'm done with that, I'm going to look at my my working ahead plan, the game design doc first, and then I'll move to the personal project doc. I reformatted it so that it looks better and should go into more detail on pretty much everything. So a lot of this is going to be the same, but I did scrap a couple things based on my trouble this week. So I had to push back the boss. All three terrains are built. The one I showed off, obviously, and then 2 extra ones for the other 2 levels. I did confirm that those do build in-game as well. I just didn't necessarily feel the need to go into those levels to show you. But upgrade the player, so essentially just fix the snapping to terrain that I wasn't able to get this time. I'm hoping I can get all that done next week, but at the very least I should be able to get it working with the face or with the plain normals, and if not, I should be okay to finish it up early next week or next sprint after that. So collision with terrain should be implemented next sprint, and just use the bullets so that they can collide and despawn with the terrain. Cap on shooting is the same. Merge in the personal project same. Make 3D models the same. Make the screens all the same. Except I'm no longer having them be clickable. I'm just having it say press enter to restart or whatever, because I don't necessarily feel that really adds anything to have them be clickable. And then using the sprite fonts to display captions for the stage number and then the health bar. And ideally, I don't think it'd be too bad to make those an engine level process rather than a game level process, so the user can just call make health bar by passing in the sprite to use, the string to use, and then the distance between the sprites, and then the sprite count. Essentially everything I'm using to make the health bar now. So just take the function I already got and shove it into the engine, which I don't think should take very long. So, and then the spinnable turrets I do also still want to keep, and then using a finite state machine to have them target ahead of the player when the player's been moving for long enough, like we talked about in class. So that's for my sprint 8, and then sprint 9 is just using the particle system, which should be finished by that point, in everywhere that I want to use it for the game. And I'm leaving myself plenty of room in case something does go wrong in these 3 sprints, so I have enough time to fix it. And then the personal project, again, is fairly similar to last time. I got this done. I'll show that in a minute. Port demo work, yep, is the same. These both are in one sprint now, but are otherwise the same. I'm no longer going to try and recreate the inputtables, but I do want to still be able to recreate the alarms so that a ship that's about to shoot will still shoot when it's supposed to. And then rewrite the recreate function so that it can recreate all different kinds of objects rather than just the enemies. And I have 2 weeks here now for the particle system, so hopefully that should be more time that I can get it done, that I have a reasonable amount of time to actually get it done. And obviously I still have game stuff to work on too, but I feel like 2 weeks is a lot better than the 1 week I was allocating myself earlier.